outlet near the pocket area that I could plug the phone into? Could I do that?
I don't know if there is or not.
But if there is, could I
there
do
is,
that?
yeah,
Okay.
yeah. It's up to you. Okay, a couple things before we get started here. So I asked for 3, 4, and 5 in the Google Classroom, and I think everybody actually did that, or at least some of them. But I always give you one last chance to turn those in for full points, so those are due before we start the quiz. So number 3 was the 4.1 notes, number 4 was the 4.1 book assignment, and number 5 was the 4.1 worksheet. Maybe if you were finishing those up this weekend and you couldn't submit them to Google Classroom or whatever, that's okay. But if that's the case, I need your hard copy with your name on them. This would be your last chance for full points. You can still turn them in between now and the test for late credit, which is half credit, but they have to be fully complete. So if you have any of those that you need to turn in, you need to do that. Secondly, I don't make you guys turn in your phones and smartwatches during every single class, but I do expect you to do that during quiz day. So if you look at your desk number, if you're in desk 15, I need your phones and smartwatches, if you have one, put into the holder on the wall over there. So it's fine if you, some people just did that early, but you need to do that before I give you a quiz. And our quiz today does need a calculator and a few questions, so if you need to borrow one, you need to come get it up here. Otherwise, go ahead and start as you get it, and then I'll give you some directions about what to do afterwards. Start as you get it. If you write anything on that, make sure you stay with it. Okay, so we do use many different forms of our quizzes and tests, so please don't be tempted to look at today's paper. Similar skills, but not the same questions, so not only would you miss it, it's usually pretty obvious. Each question does have point values on it. Anything worth more than 1 point, I do get partial credit for. But 1 point questions are all or none. I get half points. And at a quick glance, you should see that it looks like your practice quizzes, so you shouldn't have any surprises on this one. Or you should know how well prepared you're going to be. I've got some extras. Does anybody else need a calculator? Thank you. Just lay it on my desk at the end of class. All right, so I think you could probably do this quiz in, I don't know, some people could do it in as little as maybe 15 minutes. I can give you 45. We used to give a very, very similar quiz many years ago before we were on block schedule. And it was definitely achievable. So about the same amount of time. As you guys finish, so last thing and then I'll get out of your way. This is going to be number 6 in your binder. So I did not put that on there before I made copies. And it usually takes about a week for me to get these back to you. I have to give people a chance who are absent to come in during the advisory, and we don't have movement this week again, not till next week. So when you get this graded back, you're not going to know where it fits in your binder unless you number it as number 6 right now. When you finish your quiz, I need you to come put it in my basket up here. Up here by my desk is the homework tray. I've got the next handout for you right next to the tray. So you're going to turn in your quiz here and grab the next handout here. And then once you do that, you're welcome to grab your phone from the wall and wait quietly until we're all finished. Unless you're just out of time and I'm forcing you to turn your quiz in, please consider trying to check some of your work. says round to the nearest thousands, we want you to round, but it doesn't say you should just try to do that. I don't mind if you put both. Well, we should know which one's above anyway, based on the angles.
quiz, take the next handout, and then you can get your phone back and wait for everyone to finish. papers in the basket. Take the next handout and then pick up your phone before you sit back down. Thank you. And then you need this too.
Thank you.
How's the bathroom?
You'll need to wait for the pass to come back.
Alright.
Thank you. Again, please pick up your phones after I have your quiz and just find something quiet to work on. Some people may want a bit more time, so. Sure. You check that. Do you know where to find the class recordings?
No.
Okay, on that website that I asked you to look on.
Right.
And then on the left, there's like a calendar. So after class, when the class recording time, it'll be open.
Alright.
So just click it and then you can jump to the beginning of the class. Because we're gonna go over these notes, so.
Thank you.
Sorry, I just can't quite tell. Is anyone still working? It's fine if you are. Okay, then let's move on here. So I do get those graded pretty quick. So if you're just interested in how you did, some of them are in already. The rest I will have in before the end of today. But you may not see yours until everyone's had a chance to take it before I assign zeros. So you have to hold off on looking it over. I know that bugs some people to not know where they missed a point or something like that. But I also asked that you guys picked up this handout when you turned in your quiz, but it is still the start of the year, so you haven't forgotten that. Does anybody need me to bring them a copy of the next handout? Everybody remember? Good deal. Okay. Also, your phones, it looks like there's at least one more phone up there. Please go and get your phone if you didn't yet. I don't want you to forget about it and then it be stuck in here all night. So, all right. So finish up what you were working on. If you've been waiting on other people to finish, and rejoin us here. We're going to look at handout number 7, so we know what's coming up in section 4.2. So we actually do 3 sections before we do our first test. So what you just took a quiz over is going to be roughly about 1/3 of your first test. So when you get that back, you'll know exactly what to study. And then the second 1/3 of your test comes from section 4.2, where 90% of this is going to be over the unit circle. So even though you guys have heard that term before, you've probably filled in a few of them before, we use it quite a bit in here, so probably much deeper than you've seen in previous classes. I will also say that of everything we do first semester, I would say this is going to be the single most important. Not just because this is the majority of your next quiz and roughly 1/3 of your first test, but unit circle is just something that shows up in all trig stuff, and so it will be sprinkled in all semester. This is one you want to do very well with. But before I just say here's the unit circle and here's how we use it, I want you to see where some of this stuff comes from, some of the stuff that you're going to need to know. So when I say unit, this is singular. So unit circle is a circle with radius 1. Because really, if we memorize some stuff about a circle with radius 1, it's pretty easy to apply when the radius is not 1. Obviously, most stuff in real life doesn't have a circle of radius 1, but it's easy to apply. So if you take this triangle and you pretend like this is on a circle, the other thing that doesn't come up in section 4.1, which I'm kind of surprised about, but trigonometry, which is what we focus on first semester. We do a lot of algebra stuff second semester. So if you prefer algebra, you'll probably prefer second semester. Trigonometry just means the study of triangles. So if trigonometry is about triangles and you're wondering why we spend so much time worrying about a circle, it's because you can always sketch what's called a reference triangle like this within a circle. So within this, I know it's kind of small on your page, but this angle near the origin is the angle that we look from, unless we're told differently. And if this is a point on our circle, I'll just call it some generic point xy. We know that we're going some distance left or right, that's x, some distance up or down, y. And then this is not just the hypotenuse of the circle, of the triangle. In terms of the circle, sometimes we call this r. This is the radius of the circle. So we go more in depth and review SOHCAHTOA later, but we kind of need it for this first part here. So SOHCAHTOA was an acronym that helps you remember that sine of an angle can be found by taking the opposite length over the hypotenuse. Cosine of an angle can be found by taking the adjacent length over the hypotenuse. And tangent of an angle is opposite over adjacent. Now, compared to this angle here, directly across from it is the y length, but it's also the opposite because it's directly across. This radius is the radius of the circle. It's also the hypotenuse of the triangle. And then this side next to it that's not the hypotenuse, we refer to as adjacent. So instead of opposite, we could say y. Instead of adjacent, we could say x. Oops. And instead of hypotenuse, we can say r. So same old SOHCAHTOA, opposite over hypotenuse is sine, adjacent over hypotenuse is cosine, and opposite over adjacent is tangent. But we often think of these in terms of x, y, and r. In fact, in about a week, I will ask you to memorize a couple things. This will be one of those things. You don't need to memorize it right now. How this is going to be important to us before our notes are over today, though, if we're talking about the unit circle and r is 1, then sine just becomes the y value. Cosine becomes x, because y over 1 is y, x over 1 is x. And if sine is the y value and cosine is the x value of those points on a unit circle, then one way we can find tangent is called the quotient identity. You can actually do sine over cosine. Instead of y over x, you can think of it as sine over cosine. So when we talk about the unit circle on the back page here, and again, we're going to kind of build up to that, you memorize all these points, because if you have all of these points memorized for the important angles, or the most important angles, cosine ends up just being the x value at each point. Sine ends up being the y value at each point. And then if you divide those, you can calculate tangent for any of those points. So that's why we bothered to memorize those. We can get exact value of really important angles very quickly. Now, when I show you the unit circle, hopefully it looks familiar to you. I guess you can just brute force memorize it. But one thing that I do is I try to point out to you how I go about it, because I don't really memorize the unit circle. I just think about how the common ratios compare to each other. So really there's only 5 values that show up on the unit circle, if you include 0 and 1. But of course 0 is the smallest and 1's the biggest. But if you think of these other 3 as decimals, 1 over 2 is 0.5. If you did square root of 3 over 2 as a decimal, it's about 0.866. And if you do square root of 2 over 2 as a decimal, it's about 0.707. This is important to me, and this is how I keep from having to memorize so much on the unit circle, because excluding 1 and 0, which are easy to keep up with, I know when I'm looking at the big lengths, it's square root of 3 over 2. You can see it has the biggest decimal, so it's the biggest value. The next biggest links are square root of 2 over 2. It's got the next biggest decimal. And the smallest of the three common links on the unit circle is 1/2. It's got the smallest decimal. So again, you don't have to do it this way, but if you understand how these fractions compare to each other, which one's biggest, which one's smallest, you can apply the same thing to the unit circle. So I'll show you how I do that when we get to the back page. Now, you don't really need to know this next part for this class, but I do like to show you where these values come from at least once. So it's not like there was some mathematician that just said, you know, I'm going to make a bunch of math work where square root of 3 over 2 is important, and I'll make it where students have to learn all of that. So where these really come from is if you remember the two special right triangles, the 30, 60, 90. You should have seen this in the past. I've heard this is kind of helpful for ACT too, if you know these ratios, but again, you won't be quizzed on this in our class, but I do expect you to have it down for your notes. There's a ratio. So for every 1 in length opposite 30, there's 1 square root of 3 opposite 60, and 2 for the hypotenuse. 1 to 1 square root of 3 to 2. You've at least heard that before, right? You probably didn't do too much with it, but the other one is 45, 45, 90. And it says for every 1 in length opposite 45 degrees, you're going to have 1 opposite 45 degrees and a hypotenuse of square root of 2. Now, what this has to do with the unit circle is if I drew this triangle centered, just bear with me, I know that's a terrible picture, but if I center this on a circle, if I'm talking about unit circle, I don't want the radius to be 2, I want the radius to be 1. But these sides are proportional. So if I'm dividing this side in half, I have to divide this side in half, which is where the square root of 3 over 2 shows up naturally, and divide this side in half, which is where the 1/2 shows up naturally. Okay, and then same idea over here. If you made a circle out of this and you change the radius to 1, if I divide this side by the square root of 2, I need to divide this side by the square root of 2 and this side by the square root of 2. And based on my first period today, it doesn't sound like you guys rationalized in Algebra 2. You did? Okay. So we do a lot of this, so if you didn't learn it, you'll catch on pretty quickly. But basically, you multiply the top and the bottom by that square root, and then that makes the bottom a perfect square. Square root of 2 times square root of 2 would be square root of 4, but that reduces to 2. So that's where square root of 2 over 2 comes about naturally. So again, you won't have to show that to us. I just want you to know that those aren't just random numbers. They're just the same old special right triangle ratios where you fix the hypotenuse to 1 so that you're talking about unit circle. All right, also sprinkled in this section, this isn't really unit circle, but we expect you to know how to use a calculator for all 6 trig functions. So the main 3 are sine, cosine, and tangent. And early in the year, I'm not going to harp on you too much about it, but just keep in mind, you do sound a little silly if you call these sin, cos, and tan. I see why you do that, but these are just abbreviations. It's actually sine, cosine, and tangent. These are just abbreviations. So try to use the real word, because if you don't, people who really know trigonometry are going to think that you don't know what you're talking about. All right, and so to do this in a calculator, if I want to know the sine of 29 degrees or the sine of pi over 9 radians, all I have to do is type in sine of 29. But before you hit enter, your calculator is going to do this for me. But right now, my calculator is in radian mode. So if I hit enter on this, it thinks I want to know the sine of 29 radians, which is fine. I might need to know that someday, but right now I need it to be in degrees. So if you click the mode button, it's this third option that you're going to have to switch back and forth from. The first one we want in degrees, so highlight it, hit enter. Now when I type that in my calculator, it knows I want the sine of 29 degrees. So about 0.485. Okay, if I want to know the sine of pi over 9, I can just type it in. Our calculator has sine, cosine, and tangent. Even gives it its own real estate, its own little buttons here that gives you a hint on how important this stuff is to mathematics. But if I type this in and hit enter, it's going to give me an answer. There's nothing obviously wrong about this answer, but it is wrong. So what did I not do? Right, this thinks I want pi over 9 degrees, which that's kind of a weird degree, but mathematically I guess you could. So I have to go to mode, say I actually want radians. Sine of pi over 9 radians is about 0.34. So if you just want sine, cosine, tangent, your calculator can do those for you. You just have to be careful what mode you're in. If it's degrees, your calculator better be in degrees. If it's radians, your calculator better be in radians. Now, did you guys know that there's actually 3 other trig functions? There's actually 6. Okay, good. I'm seeing some head nods. So the other 3, your calculator does not have a button for these because it realizes that if you are working with these, then you should know how these relate. So one of them is cosecant, one is secant, and one is cotangent. And these are the easy ones to work with. Because secant is just really the reciprocal of sine. Remember, reciprocal just means you flip your fraction. So like the sine of 30 degrees is 1/2. So the cosecant of 30 degrees would be 2. 2 and 1/2 are reciprocals. Secant is the reciprocal of cosine, and cotangent's the reciprocal of tangent. So again, these are really easy ones to work with after you practice it a few times. But early in the year, you have to keep straight which is which. So cotangent and tangent, students usually catch on quickly because they sound alike. And then the only tip I have for you on the other 2 is I remember when I was in high school, I thought cosecant and cosine should be reciprocals because they both start with C, and secant and sine should be reciprocals because they both start with S. Unfortunately, it doesn't work that way. It's the other way. But if you want to know something like the cosecant of 35, your calculator doesn't make a cosecant button because you can just do 1 over the sine of 35. And if you're doing something like cosecant, you should know the reciprocals. So I need to make sure my calculator's back in degree mode. But otherwise, I can just type it in the way I wrote it. You need to make sure you put that on your notes there because the answer to this is not important. What you need to type in your calculator is important. That comes out to be 1.743. About 1.743. Yeah.
Can't you also just do second sine?
That is inverse sine, and that means something different. Reciprocals and inverse functions, I'm glad you asked that. So reciprocals is where like you flip your fraction over. Whereas inverse, which is like the little -1 looking exponent thing, this is where you, and we actually do a whole section on this later this year, that's where you switch your input with your output. But not the same thing. Okay, so how do you guys think, if we put this on your test, how do you think you're supposed to find the cotangent of 5 pi over 11? Very good. You just have to know cotangent's the reciprocal of tangent. Your calculator better be in radian mode, so I have to switch it back again. But otherwise, bless you. One over the tangent of that angle is the same as the cotangent. By doing 1 over, that's how you do reciprocals, or an easy way to do reciprocals. So it's about 0.144. Or I'm sorry, 0.144. Big difference. So make sure you emphasize this part of your notes, what gets thrown in the calculator. Sine, cosine, tangent just works. There's a button for them. Secant, cosecant, and cotangent can also just work, but you have to know how to type them in. Okay, I'm gonna pause for just a second. Is there anything that jumps out at y'all about what we've currently talked about you want clarification on? Okay, then I gotta show you one thing that shows up in this unit, and this isn't going to mean too much to you right now, but I need you to have it in your notes as a resource. Then I'll show you how I would construct a unit circle and show you a few examples, and that will be it for class today. So we expect you to know what trig functions are even and odd, which you can memorize. There's 2 of them are even, 4 of them are odd. But more important than that, you need to know what it means to be an even function and an odd function. So it's been many years, but I used to teach the Honors Algebra 2 classes, and for an odd function, the easiest one to memorize would be x cubed. And I like to visualize it to help me out here. Because x cubed, if I plug in 2, I get 8. If I plug in -2, do I also get 8? What do I get instead? -8. So an odd function is when you plug in the opposite x value and you get the opposite y value. So how we write that in trig is sine is an odd function. So whether I plug in a positive angle or the negative version of that angle, like 30 or -30, the only way these are going to be equal is if I multiply 1 by a negative. Just like 8 times -1 becomes -8. But cosecant is also odd, so it's equal if you multiply 1 by a negative. Tangent is odd. No, sir. You need to, don't just take the pass. You need to leave your phone or put your name on the board. And cotangent is odd. Again, this isn't going to mean much till you see a few questions. No, not there. That's for make-up quizzes. Over to your left. Look at the left side of the board. I've got directions. You can just put your name underneath it. So how this is helpful to us is like when we memorize the unit circle and we're going to know that sine of 30 degrees is 1/2. Well, that tells me that the sine of -30 degrees would be -1/2. It's just the opposite version of it. Whereas the only 2 even functions are cosine and his reciprocal. And just to give you a quick example of what it means to be even, I use x squared as an example. Whether I plug in 2 to get 4 or -2 to get 4, whether I plug in a positive x or a negative x, I get the same value. So whether I plug in a positive angle or the negative version of that angle, these will be equal. Positive or negative, they have to be equal. So realistically, again, you don't have to worry about this between now and Wednesday, but memorize the 2 even functions are cosine and its reciprocal, the other 4 are odd, and then at some point you'll need to know what it means to be even and odd. Even stays the same, odd is only equal if you multiply 1 by a negative. But for now, just make sure that you have that down as a resource to look back up later. Okay, so again, a couple random things in there, but now we can get to constructing the unit circle. So all unit circle questions kind of boil down to 3 to 4 steps. So one example could be, just write a few up here, like what is the sine of 30 degrees? Well, the first step is you have to know where this angle is. So some of the problems will be in degrees. Some of the problems will be in radians, so we need to know the degrees and the radians. Now, we don't memorize all 360 degrees, because that would be way too much, but we memorize 3 from within each quadrant. So, how big is this angle right here? Yes, let's just start with 0. This is where we start, standard position, and the angle doesn't open up at all. Well, for degrees, the big jumps are 30 degrees, so this would be where 30 is, and the small jumps are 15. So add 15, add 15, add 30. Hopefully you knew 90 was there already. Big jump, add 30, small jump, add 15, small jump, add 15, big jump, add 30. Hopefully you knew 180 was right there, and then you can keep going. Small jumps 15, big jumps 30. And then when we get back to the end, we get what? What's the last one? 360, which confirms what we already know. So to answer this question 1 that we'll do in just a second, the first thing is knowing where 30 degrees is. So I should be looking at this point. Now, sometimes it's in radians though, so we need to be able to also find where pi over 6 is. So I do kind of a similar trick, but you've got to do 2 of them this way. So I think about it this way, and again, this isn't the only way, but typically this is what works best for students. I know halfway around a circle is pi radians. I just memorized that one. So if you can imagine cutting this pi radians into 6 equal slices, and I'm going to try to draw that to help you see, but here's a slice, 1, 2, 3, 4, 5, and 6. If I cut that into 6 equal pieces, what I can do is just add those up as I go around. So add it, and I get 1 pi over 6. Add it again, you get 2 pi over 6. Add it again, you get 3 pi over 6. Add it again, you get 4 pi over 6, then 5 pi over 6, and then 6 pi over 6. All I did was reduce the fractions that reduce. So again, knowing how much 1 pi over 6 is gets all of those. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, and then reduce. And the fact that we memorize this one's pi gives us that check as we go around. Now we can keep doing that down here. Add it again to get to 7 pi over 6. Again for 8 pi over 6, reduce. 9 pi over 6 reduces. 10 pi over 6 reduces. 11 pi over 6. And then if I add it again, I get to 12 pi over 6. And what does 12 pi over 6 reduce to? 2 pi, which we're also supposed to know is all the way around. So again, if you know how much 1 pi over 6 is and you just add it 12 times, you get almost every radian that you need. We can do a similar trick for the last 4. Now again, you guys are just welcome to straight up memorize this thing. It's just I'm trying to show you some tips on where you can kind of work with it without memorizing. Okay, so now I'm going to divide this pi radians into 4 equal parts, 4 equal slices. So there's 1, 2, 3, and 4. So now I know this is 1 pi over 4. Add it again, you get to 2 pi over 4. That reduces, and we had it already anyway. Add it again, you get 3 pi over 4. Add it again, you get 4 pi over 4. Already knew that one. Add it again, you get 5 pi over 4. Add it again, you get 6 pi over 4. Already had that one. Add it again, 7 pi over 4. Whoa, Lena. Lena. You need to sign out if you're going to take the bus. Did I pronounce your name right?
What?
Did I pronounce your name okay?
It's long.
Lana? Sorry. Oh, you put your phone. I'm sorry. I'm sorry. I'm so used to y'all just putting your name. I'm used to it being the start of the year, so. Okay, so that got me the rest of the radians. Are you guys okay with where those came from? So, like, just randomly, again, I'm not going to do the whole thing from scratch. But let's say there was a question about something at 5 pi over 4. I know this is where 1 pi over 4 is, and then I just count it 5 times. 2 pi over 4, 3 pi over 4, 4 pi over 4. Here is 5 pi over 4. Just understanding that is enough for me to know that's in the middle of that quadrant without spending all day reconstructing this. All right, so knowing the location of each of these angles is always going to be step 1 for each of these questions. Step 2 is you have to know the point at each of these. This is where some of the stuff we did on the front page there. So the easiest ones are going to be these. These are called quadrantal angles. If I go directly to the right, this point is 0, 1, because remember this is unit circle, length 1. If I go straight up, it's 0, 1. Left is negative 1, 0. And then down is 0, negative 1. Just knowing it's unit circle, all your distance going up, down, right, or left, you can get those. And then my trick for the others, again, this is to try to keep you from memorizing as much. For the other ones, we talked about their decimals on the other page. This was slightly bigger than this, was slightly bigger than this. So at 30 degrees, it looks like it's got the biggest of the x values. So the biggest one is square root of 3 over 2. And the smallest of the y values, 1/2. At 45 degrees, the x value is a little bit smaller and the y value is a little bit bigger. So a little bit smaller is square root of 2 over 2. A little bit bigger is square root of 2 over 2. And then one last comparison. To get to 60, I need the small length, which is always 1/2. And then the big length, which is square root of 3 over 2. So just knowing how those three compare to each other, you can just think about how those lengths compare to each other. Now, by far, quadrant 1 is the most important one. The rest of this is going to fall into place real quick, so you don't want to blink here. Once you memorize quadrant 1, this angle at 30, 150, 210, and 330 all are very, very similar because the distance x and y, x, y, x, y, x, y, all of those have the same distance x, square root of 3 over 2, and distance y, 1/2. Okay, but there's one slight catch to that. What do these three have different than this one? Okay, if you're in quadrant 2, you're going left and up, so this one's negative. In quadrant 3, you're going left and down, so they're both negative. And in quadrant 4, you're going right and down, so the y is negative. But otherwise, they're the same lengths. They have the same x length and same y length. So all three of these red dots are almost the same point. You just have to be careful about which one's positive or negative. Likewise, in the middle of each quadrant, you've got the middle x, middle y. So in the middle of this quadrant, middle x, middle y. In the middle of this quadrant is middle x and middle y. And in the middle of this quadrant, you have middle x and middle y. So they're going to have the same x lengths and same y lengths. Just be careful that in quadrant 2 you're going left, so x is negative. Quadrant 3 you're going left and down, so x and y are negative. And in quadrant 4 you're going right and down, so y is negative. Otherwise they're the same thing. I know there's a lot on my screen here, but all of these purple dots are almost the same, other than signs. And then if we do this one last time, I'll do this one in gray, I guess. This one has the small x and big Y, but so does this point. Small x and big Y. So 1/2 square root of 3 over 2, but the 1/2 should be negative because you're going left. Down here at 240 degrees, you've got small x and big Y. So small is 1/2, big is square root of 3 over 2. But in quadrant 3, you're going left and down, so make them both negative. And then this last guy right here, small x, big Y. Small is still 1/2, big is still square root of 3 over 2. This one you're going right, so x should be positive, and down, so y should be negative. But otherwise, those points are the same. All right, I know I don't have the best handwriting, and I've been zooming in and out here. So is there any of these you want me to make sure, double check your work too? Okay, let's look at just a couple practice questions so you can see how we are going to ask you to use this. And if nothing else, just emphasize to you how important this is going to be. So I already made up 2 problems here. The sine of 30 degrees is one that we will expect you to give us an exact answer to without a calculator. So you have to know where 30 degrees is. You have to know the point there. It's square root of 3 over 2, 1/2. And then just like we talked about at the very, very beginning, if you're talking about the unit circle, cosine is just the x value and sine is the y value. So that's why we care to memorize those points. So if I wanted the sine of 30, it's going to be the y value 1/2. Okay, question 2 is basically the same thing. You should be able to locate pi over 6, step 1. You need to know the point at pi over 6, step 2. And step 3, you need to know that cosine is the x value and sine is the y value. Since these are really the same angle, those are really the same question. Okay, but it could also be like, what's the cosine of 5 pi over 4? So find 5 pi over 4. And since it's cosine, we want the x value there. So that would be not square root of 2 over 2, but that's close. Should be negative. So now I don't normally construct an entire unit circle. I'll say some students do early on in the year, but what I would suggest you do is just this. Say 5 pi over 4, here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. And then that's close enough for me to see this is middle length, middle length. Square root of 2 over 2 is the middle one, but I'm going left and down, so they're both negative. And since I wanted cosine, I wanted the x value. So you don't have to reconstruct the whole unit circle to be able to do that. All right, why don't you all tell me, how do you think you go about finding the sine of, I don't know, 120 degrees? What would be the first thing you need to do to answer this question? Okay, well, assuming you don't have unit circle in front of you, but find the angle. Okay, so if you can find the angle with some accuracy here, I know this is where 90 is, and 30 more would be right here. So there's 120. What is the point at 120? Okay, and now I saw a lot of you looking at your paper, but again, the way I tried to compare those values for you so that you don't have to. This is small x length, 1/2, big y length compared to the other 3 points, square root of 3 over 2. Going left, negative, up, positive. And then which one of these two should be my answer? Yeah, the y value. Sine is the y value. Okay, we're going to do 2 more, and then that will be it, because I need you to see that it gets deeper than that. This is where students often come into this class and they think, okay, I already know the unit circle. But if you know the unit circle, then you should be able to do something like the tangent of pi over 3. That type of question will be on your quiz and on your test. It's going to be hard for you at first, but while we practice it. So it starts off the same way. You have to do enough work to know where pi over 3 is. I memorized where pi over 6 is, and then I add it again. This would be 2 pi over 6, but that's the same thing as pi over 3. Because I can see where that is in this quadrant, I can see I've got small x value, which is 1/2, and big y value, which is square root of 3 over 2. So if I wanted the cosine of pi over 3, my answer would be 1/2. If I wanted the sine of pi over 3, it'd be square root of 3 over 2. But how does that help me find tangent? Right, we have this thing called the quotient identity that we use all the time. We're going to use it into the ground. So if you want to know tangent values, you can just do sine divided by cosine. So for this question, you'd have to say, here's the sine. Divide. Sorry, give me just a second. Okay, so here's the sine of pi over 3 divided by the cosine of pi over 3. Tangent is always sine divided by cosine, and so you're going to have to know how to divide your fractions, change it to multiply by the reciprocal, and with that, without a calculator, we can give exact value of tangent values as well. So there's number 5. And then last one, how about secant of I don't know. Let's do 7 pi over 6. So you have to be able to find 7 pi over 6, either through memorization or what I suggested. You've got to see that it's the big x length in the negative direction, small y length in the y direction. Or just memorize the point if you prefer to go that route. Actually, I'm sorry, let's change this just to make it just a touch easier for now. So we haven't talked about the other one. Let's change it to cosecant. This would be the cosine of 7 pi over 6, and this would be the sine of 7 pi over 6. How does that help me find the cosecant of 7 pi over 6? Right, knowing that cosecant's the reciprocal of sine, and so if I flip over the answer to the sine of 7 pi over 6, I have the answer to the cosecant of 7 pi over 6. So in calculus, that's what we actually need. I'm one of our 2 Cal AB teachers, and in calculus, sometimes you do some limit work, and we do a little bit of limits in here, but ultimately it comes down to something like this. If you plug in 7 pi over 6, can you find the cosecant? So you have to answer any of these, you have to know the locations, you have to know the points, you have to know cosine's the x value, sine's the y value. Sometimes you have to flip those over to get secant or cosecant. Sometimes you have to do sine divided by cosine to get tangent, and you can flip tangent over to get cotangent. And then you can find all 6 trig functions for any of these angles, exact values, no rounding, and without a calculator. So hopefully that at least convinces you that it's going to be important, and if you thought you knew the unit circle, I hope that makes you at least realize that we're using it much more in depth than you had to do in previous courses. So, all right, so we've still got about 7 minutes till you're dismissed, but that's all I need from you today. I don't have homework that you need to do. Okay, we'll have to do 8 next time. My other class didn't have time for that either. Not homework that you need to write down pencil to paper, but please spend just a 5-10 minutes scanning these notes before class on Wednesday. Scan the unit circle, think about how it's pieced together, because that will make class on Wednesday go that much smoother for you. So you don't have to memorize it yet, but start thinking about it.